class. Today we're going to be talking about parent functions and transformations. On the standardized test practice problem, we have a piecewise function that gives the amount of money earned for working different numbers of hours. How much will an employee earn for working 12 hours? So we find the piece of the function that represents where 12 would be, and this would be in this part right there. So what we would do is do 8.5 times 12 minus 1. 8.5 times 12 minus 1 is 102 minus 1. So our answer is $101. Parent graphs. The parent graph, which is the graph of the parent function, is the simplest of the graphs in a family. Each graph in a family of graphs has similar characteristics. Each graph in a family of graphs has similar characteristics. The graph that's characteristic is a straight horizontal line, or that can be written in the function y equals a, where y is any real number, is called a constant function. Constant. The function that's characteristic is a straight diagonal line, would be in the form of y equals x or y equals mx plus b. This is called a linear function. The function whose characteristics included diagonal lines shaped like a V, and the way I help remember that is because V, an absolute value, V value, that's just a corny way, but that's how I remember. This is the absolute value function. And the function whose characteristic is a curved line or a U-shaped line is a quadratic. Function. I remember the U shape to go with the U in quadratic. So we're going to look at some examples of identifying the type of function represented by each graph. You can see in example A that the graph is a diagonal line, so this represents a linear function. In B, the graph is a parabolic curve. The graph represents a quadratic function. It's parabola. Down here in example 1, this function is the absolute value, the V shape. Absolute value. And on number 2, this graph, when it's got a straight horizontal line, this represents a constant function. Meaning the value of y always stays the same. Here y is at 3, or y equals 3 is the function. Transformations of a parent graph may appear in different locations, may flip over an axis or may appear to have been stretched or shrinked. Actually, let's use the word compressed instead of shrinked. Stretched or compressed. Example C, describe the reflection in y equals the opposite of the absolute value of x. Then graph the function. The graph of y equals the opposite of absolute value of x is what is called a reflection. See how it flips over the parent function? Here's the parent function, y equals the absolute value of x. Here's the reflection. So this is a reflection. Of the graph of y equals the absolute value of x. Okay, I think I'll move these up to graph. So what we're going to do is we're going to use a dotted line, and I'll use it in blue, to represent each parent function. So I'm just going to go through here and show you the parent function. Parent function, or the translation of the graph of the parent function y equals x looks like this. If y equals x, then when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3, etc. So it would be, here is the parent function, and I was going to represent it by a dashed line. Line. This translation is 4 units down. So when I draw translation, I'm going to take each point and bring it down by 4 units. So I'll just start with this point. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, etc. You see the pattern? Here is the translation. And I probably should put arrows on the ends. Okay, this is the absolute value function, or it's going to be a translation of the graph of y equals the absolute value of x. So the way I can tell you points would be the absolute value of 0 is 0, of 1 is 1, of 1 is 1, of 2 is 2, of negative 1 is 1, of negative 2 is 2, of negative 3 is 3. So you get the idea. Let's do dashed lines. And put arrows on the end. Okay. Now, this, you can see the translation is 5, and it says plus 5, but this is tricky, but you're going to do the opposite. So you're going to go, instead of right 5, when it says plus 5, you're going to go left 5. 5 units left. So take every point and move it over by 5 units. I'll start with this point. So I'm going to go left 1, 2, 3, 4, 5. And I'm going to go left, let's see, I did that one. Left 1, 2, 3, 4, 5. And I'm going to go this point, left 5, and then I'm gonna take this point and go left 5, 1, 2, 3, 4, 5, and I'm gonna do the same thing with this point, 1, 2, 3, 4, 5. 5 left, so then connect the points. And you can see that we just translated or slid the parent function 5 units left. The final example is going to be a translation of the graph y equals x squared. This is the quadratic function. You can see that it says -3. That means we're going to go 3 units down. I should mention that up or down is outside of x, meaning if you do something to x, it's grouped in either absolute value, symbols, or parentheses. If it's not grouped in those symbols, then and it's a minus or a plus, then that's an up or down movement. So the parent function of this quadratic formula would be if x is 0, or 0 squared is 0, 1 squared is 1, 2 squared is 4, -1 squared is 1, -2 squared is 4. So our parent function looks like this. Keeps going. And what we're going to do here is just simply take each point and move it 3 units down. So we'll start with this point. We'll go down 3. 1, 2, 3. Take this point, down 3. 1, 2, 3. Take this point, down 3. 1, 2, 3. This point, 1, 2, 3. And this last point we had, 1, 2, 3. So here is the translation. It's just been shifted down 3 units. And that is our lesson on transformations of parent functions. I hope that you will enjoy doing these, and I also hope you have a great day. We'll see you next time.